Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is second class in three-dimensional geometry, class 12. In class 1, what we learn? We learn what are direction cosines of a line, what is direction ratios, and important points related to direction ratios, and we completed first exercise problems in this first class of three-dimensional geometry, right? Now this is second class. In this class we are going to learn about equation of a line. Look here, equation of a line. In two-dimensional geometry, straight lines chapter, you learn about equation of a line. In that many lines are there, 2-point form, point slope form, intercept form. You learn those things in two-dimensional geometry. In three-dimensional geometry, equation of a line in a space. In two-dimensional geometry, equation of a line in a plane. Plane means flat surface, right? So, equation of a line in a space. Total two types of equations of lines are there in three-dimensional geometry. This is important. About learning about equation of a line in three-dimensional geometry is important. You observe here, we are going to derive two things here. Derive the equation of a line passing through given point and parallel to given vector. Parallel to the given vector. Right, this I'll explain all the things clearly. You must have patience to understand 3D geometry, right? Next, another equation of a line passing through 2 points. We'll write those 2 points as x1 y1 z1, x1 y1 z1, x2 y2 z2. Equation of a line passing through 2 points in both vector form and Cartesian form. And we'll do this one also, angle between two lines formula. We will derive this. So these three results we are going to do in this video. Another thing is also there, skew lines and distance between skew lines, shortest distance between the skew lines, that concept is also there, that we will do in the next video. So in this video mainly we are going to learn these three things. Equation of a line in a space. Total two types of equations of lines, and third one is angle between two lines. Okay, so without much delay we will begin the class, right? Equation of a line in space. Right, what is this question? Derive. We need to derive equation of a line. What line? That line is passing through the point A. That line is passing through the point A, and whose position vector is A bar. I said in the beginning only, if you want to learn 3D geometry, you must be good in vector algebra chapter, right? If you are not good in vector algebra chapter, please learn vector algebra first. If you don't know what is position vector, understanding 3D geometry is complicated one actually, right? However, I'll explain, okay? And parallel to given vector B bar in both vector and Cartesian form. Total two forms will be there to represent a line. One is vector form, another one is Cartesian form. Both the things we will discuss. First, we will try to understand what type of line equation we are finding. I'll draw one line here. Yes, I'll draw one line. Suppose this is the line equation. This is the line equation we are trying to find. We'll name this as line L. Okay, this is line L. This line L passing through point A. Look here, there is a line which is passing through point A. I taken A as x1, y1, z1. Okay, you take this is passing through point A. I suppose this is point A, and A is x1, y1, z1. 1 minute. X1, y1, z1 passing through point A, whose position vector is A bar. What it means, whose position vector is A bar means, if A is a point, then OA bar is called position vector of point A. See, O is origin here. OA bar is called position vector of point A. OA bar equal to A bar. And given that this line is parallel to one vector B bar. Main thing is we are finding a line equation which is passing through point A, and that line is parallel to the vector B bar. These are the main things, right? I'll draw one vector which is parallel to B bar. Here I suppose this is B bar, and we know that a vector is represented by a directed line segment. I'll suppose this is B bar. Okay, So what we are doing, we are finding this line equation. Please observe here, we are finding this line equation. This line is passing through point A. A is x1, y1, z1, and this line is parallel to vector b bar. See, while learning line equation in two-dimensional geometry, you learn like this. There is a line which is having slope m and passing through the point x1 comma y1. What is the equation of a line passing through point x1 comma y1 and having slope m? This is point slope form. We learned in straight lines chapter, two-dimensional geometry. What is that? Y minus y1 equal to m into x minus x1. This is the equation of a line point slope form. Equation of a line in two-dimensional geometry. Right? This is also similar like that. What they are saying, this is the line. This line is passing through the point x1, y1, z1. And this line is parallel to the vector b bar. Okay, we need to find this line equation. We need to find this line equation in both vector as well as in Cartesian form. Both vector form as well as in Cartesian form. I hope you are understanding. Okay, so let's start the proof of this derivation. We need to derive this line equation. Okay, proof of this. Proof. First, I'll write few things which are needed. Okay, first one, let these things takes time to write. Please have patience. Let L be a line. Okay, passing through. This is the line L. This is the line L passing through. Passing through. What? Okay. Passing through x1 comma y1 comma z1. Passing through point A. I'll name that point as A. L be the line passing through point A, x1 comma y1 comma z1, and whose position vector is A bar. Whose position vector is A bar and parallel to given vector b bar. I consider a line L. That line is passing through point A, whose position vector is A bar. That means OA bar is A bar, and that line is parallel to the vector b bar. Here I will write few things here. What is OA bar? OA bar is position vector of point A. We taken it as A bar. Position vector of point A is OA bar. OA bar is A bar. Right. And when we know point A, we can write its position vector. When we know point A, we can write its position vector. In vector algebra chapter you learn now. If P equal to x comma y comma z, what is OP bar? OP bar is xi cap plus yj cap plus zk cap, like that. What is OA bar? OA bar is x1 I cap plus y1 j cap plus z1 k cap. Okay, OA bar. Right. Now we need to find this line equation. To find this line equation, what I'll do, I'll take a point on the line. See, this is the line L. We'll do one thing, change this color. See, this is the line L. On this line, I'll take one point P. Suppose here I'll consider a point P. Okay, this is the point P. I'll take P is x comma y comma z. You take let. This is the second point. You better write it as a points wise. You don't mark like this, but points wise. First point is over. Second point. Let P of x comma y comma z is a point. On the line L. Be a point. Be any point on the line. Be any point. Is any point on the line L. Okay, such that I am taking such that OP bar equal to R bar. What is OP bar? OP bar means what? OP bar is position vector of point P. You know OP bar. OP bar equal to R bar. As we know point P. P is x comma y comma z. Na? What is OP bar? Yes, what is OP bar? OP bar is x I cap plus y j cap plus z k cap. OP bar is x I cap plus y j cap plus z k cap. Okay, what we need to find? We need to find this line equation, right? For that, what they given? They given that this line, see here, this line is parallel to this vector, right? I'll write that only from figure. From figure, or else it is given from figure. What we can understand, AP bar. P is the point on the line we taken. Look here, AP bar. AP bar means this vector. AP bar is parallel to B bar because this line is parallel to B bar, right? So from figure, what we can say, AP bar comma B bar are parallel. I hope you are understanding. Parallel. AP bar comma B bar are parallel. We know that in vector algebra chapter, parallel vectors are also known as collinear vectors, right? So here, if the vectors are collinear, if two vectors are collinear, vector algebra chapter knowledge, if two vectors are collinear, then one vector can be expressed as scalar multiple of another vector. One vector can be expressed as scalar multiple of another vector. This is one vector. This can be expressed as scalar multiple of another vector. This knowledge we have from vector algebra chapter. Here lambda is some scalar. Here lambda is scalar. If two vectors are parallel vectors are also known as collinear vectors. That's why I am saying vector algebra chapter knowledge is also needed. However, if you don't know also, it's okay. What point you need to know, if these two vectors are parallel vectors are also known as collinear vectors. If two vectors are collinear vectors, one vector can be expressed as scalar multiple of another vector. Okay. I again a vector algebra concept. AP bar is there na? AP bar, suppose AB bar is there. AB bar can be written as OB bar minus OA bar. Triangle of vector addition. Triangle of vector addition. AB bar can be written as OB bar minus OA bar. Here AP bar is there na? AP bar can be written as OP bar minus OA bar, right? Here this AP bar is there na? This AP bar can be written as OP bar minus OA bar equal to lambda B bar. What we are trying for? We are trying to find equation of a line in both vector form as well as Cartesian form. Both vector form as well as in Cartesian form. First we are trying for this vector form. What is the vector form of a line passing through point A and parallel to the vector B bar? Okay, we almost got it. From this, what is OP bar? What is OP bar? OP bar is R bar. You only written here now. Look here. OP bar. We taken this. Let OP bar equal to R bar minus A bar. OA bar. What is OA bar? Position vector of point A. Look here. What is OA bar? OA bar is A bar. R bar minus A bar equal to lambda B bar. Okay. From this, what is R bar? R bar equal to, you take minus A to the right hand side part, what you will get? R bar equal to A bar plus lambda B bar. What is this? R bar equal to A bar plus lambda B bar. This is the equation of a line in vector form. This is the equation of a line passing through point A parallel to the vector B bar. Passing through point A whose position vector is A bar, OA bar is A bar. So we derived the first one. We derived vector form of equation of a line. So R bar, I'll write here. Let it take steps also. R bar equal to A bar plus lambda B bar is the equation of a line. Equation of a line in vector form. You can write some other steps also. Equation of a line passing through point A whose position vector is A bar and parallel to vector B bar in vector form. The simplest form. R bar equal to A bar plus B bar. A bar plus lambda B bar is the equation of a line in vector form, especially in this case. I hope you understand. See, they are asking to derive the equation in vector form. We derived. This is important. Derivation they are asking in exam also, right? Now, you need to memorize this formula. While doing the problems, they will give, find the equation of a line. Find the equation of a line which is passing through the point 2, 3, 4 and this line is parallel to vector I cap plus j cap plus k cap, something they give like this. At that time, you need to know this is the vector form of a line when a line is passing through point A whose position vector is A bar and parallel to the vector B bar. You need to memorize this result. R bar equal to A bar plus lambda B bar is the equation of a line in vector form. Okay, right. Now they are asking us to derive in Cartesian form also. Na? Look here, they are asking us to derive the equation in Cartesian form. So we will derive this in Cartesian form. Okay, Cartesian form derivation. Cartesian form. I am deriving the equation of a line in Cartesian form. Okay, deriving the equation of a line in Cartesian form. Okay. To derive these things, you observe this is the vector form. Na? I need what is R bar, what is A bar, what is B bar. R bar. What is R bar? R bar is already there here. Where is that? R bar. Look here. R bar equal to, right? This is R bar. Okay, I'll write what is R bar. R bar equal to xi cap plus yj cap plus zk cap. Now I need A bar also. What is A bar? Look here. A bar is there here. A bar equal to this one, x1 I cap plus y1 j cap plus, I'll write that one also. What is A bar? Okay. Now I need one more thing. What is this? B bar. What is B bar? Actually, in the question only they'll give. Look here. Equation of a line parallel to the given vector B bar. Parallel to given vector B bar they'll give in the question. Right? So I'll take here B bar equal to, I am taking here, let B bar equal to A I cap plus B j cap plus C k cap. This vector they'll give in the question while solving equation of a line in Cartesian form, right? Find the equation of so and so line which is parallel to so and so vector, right? What I am trying to say, while doing the problem they'll give this in the question only. Okay, now we need to derive the Cartesian form. To derive the Cartesian form, what is the vector form? Look here, this is vector form. R bar equal to A bar plus lambda B bar, right? R bar equal to A bar plus lambda B bar. What is this? This is the vector form of equation of a line. From this only we will get the Cartesian form. Okay, what is R bar? Look here, xi cap plus yj cap plus zk cap. In place of R bar you write that one. In place of R bar you write that one, equal to A bar. What is A bar? A bar is this one, right? Write that one, A bar. Okay, x1 I cap plus y1 j cap plus z1 k cap. R bar equal to A bar plus lambda times of B bar. What is B bar? Is there here? They'll give this B bar in the question, right? Copy. Okay. Now little bit of simplification I will do this side. Okay. See here what I will get here. Here I cap is there. Here also I cap is there. First you multiply with lambda. Then right hand side part what you will get, x1 plus lambda a into I cap. Okay, similarly you simplify this one, this right? What you will get? You will get y1 plus lambda b into j cap. Okay, plus z1 plus lambda c into k cap. This side, this is as it is, xi cap plus yj cap plus zk cap. Okay, now you see this is one vector, this is another vector. I will compare the scalar components. Here what you will get, x equal to x1 plus lambda a, right? X equal to x1 plus lambda a. Okay, y equal to y1 plus lambda b, z equal to z1 plus lambda c, right? I'll get these things as these two vectors are equal. I hope you are understanding. Just equating scalar components, you will get this. Now equate these two, you will get this. Now equate these two, you will get this. Okay. Now I'll try to write lambda from this. What is lambda from this? You take x1 to this side, x minus x1, x minus x1 equal to what? Equal to lambda a. You take a to the left hand side part, you will get like this. Then you will get lambda. I'll write direct step. It's already becoming lengthy. X minus x1 divided by a equal to lambda. Similarly, try to write lambda from this. What you will get? Y minus y1 divided by b equal to lambda. Next, z minus z1 divided by c equal to lambda. Now you equate what you will get. X minus x1 divided by a equal to y minus y1 divided by b equal to z minus z1 divided by c. All these are equal to lambda. See, this is equal to lambda, this is equal to lambda, this is equal to lambda. All are equal to lambda. What is this? This is a Cartesian form of a line passing through point A parallel to the vector b bar. See, this is a method. This is a method of representing a line in Cartesian form, right? This is also known as symmetric form, right? This is method of representing a line equation in Cartesian form. I hope you are understanding, right? So, what they are asking in the question? They are asking in the question, derive the equation of a line. 1 minute. Derive the equation of a line passing through point A whose position vector is a bar and parallel to vector b bar is in Cartesian form and vector form. What is the vector form? R bar, you need to memorize these things. You need to memorize these things. R bar equal to a bar plus lambda b bar is the equation of a line passing through point A whose position vector is a bar and parallel to the vector b bar is the equation of a line in vector form, right? Similarly, what is the Cartesian form of a line passing through the point A and parallel to the vector b bar? X minus x1. You need to memorize these things. X minus x1 divided by A equal to y minus y1 divided by B equal to z minus z1 divided by C. What is this? This is equation of a line in Cartesian form. Okay. So, these two things you need to memorize because while solving the problem they'll ask find the equation of a line passing through so and so point and parallel to so and so vector. In that case, if you know these formulas, then we'll just apply the formulas and we'll get the answer, right? So we are in deriving equation of a line. In that, first one is over. Next one more is there, deriving the equation of a line passing through 2 points. Before that, one note point is there. Here, what are ABC? What are ABC? ABC are the direction ratios of B bar, correct? In last class, we discussed for a line, direction ratios are not unique. You please check the last video. In that, we discussed more clearly about direction ratios. Here, what is the note point? Suppose they given like this. If L comma M comma N are the direction cosines of a line, passing through point, direction cosines of a line passing through x1 comma y1 comma z1 is then its equation is x minus x1 divided by L equal to y minus y1 divided by M equal to z minus z1 divided by N. Actually, this is the equation of a line. When a line is parallel to ai cap plus bj cap plus ck cap, I hope you are understanding. When a line is parallel to ai cap plus bj cap plus ck cap, that means ABC are the direction ratios of a given line. That respective line is parallel to b bar, na? The line is parallel to b bar. Look here, this line is parallel to b bar. What is b bar? We taken here b bar equal to, where is that b bar? We taken here b bar. Look here, we taken b bar here. ABC are the direction ratios of given vector. ABC are the direction ratios of given vector. If we know direction ratios, okay. If you know direction cosines also, look here, if L comma M comma N are the direction cosines of a line, because direction cosines also acts as a direction ratios. We discussed this in first video, direction ratios concept, right? So what is this? From this, what you can say? This is equation of a line in Cartesian form. Which line? That line passes through the point x1 comma y1 comma z1 and parallel to which vector? Parallel to the vector li cap plus mj cap plus nk cap. That's it. Right? I hope you are understanding. Right. Now we'll do that second one. Deriving the, look here, derive the equation of a line passing through 2 points. Passing through 2 points x1 y1 z1 x2 y2 z2 in both vector and Cartesian form. Here also we are finding a line equation. Okay, finding a line equation. We are finding one line equation. The line is like this. Okay, that line is passing through 2 points A and B. What is A? A we will take it as x1 comma y1 comma z1. B we will take it as x2 comma y2 comma z2. What we are doing? We are deriving this line equation. This line is passing through 2 points x1 y1 z1 x2 y2 z2. In what way? We need to derive in two forms. One is vector form, another one is Cartesian form. Right? How to derive? In last one, what is the difference between last one and this one? In last one they given 1 point and they are saying that that vector is parallel to B bar. In this they are just saying find the equation of this line. You just find the equation of this line which is passing through 2 points. Okay, right. So first we'll write the steps. There is a line L, we'll name this line as L. There is a line L which is passing through 2 points such that their position vectors and all the story we'll write. Okay, so derivation, while deriving this, first step, let L be the line. Let L be the line passing through. Let L be the line passing through 2 points. We'll name them. A is x1 comma y1 comma z1 and B is x2 comma y2 comma z2. Okay, such that OA bar, that means position vector of point A is A bar and OB bar equal to B bar. I consider a line which is passing through 2 points A and B such that position vector of point A, position vector means OA bar is A bar. I am taking this, look here, let I written. OA bar is A bar and OB bar equal to B bar. Position vector of point P is OB bar. Here as they given point A, can you write OA bar? Yes, we can write OA bar. Even though if it takes time, I'll write all the steps. OA bar equal to A bar. What is A bar? Look here, OA bar. What is OA bar? When they given the point, we can, every point can be expressed as in terms of its position vector. We learned this in vector algebra chapter. What is OA bar? OA bar is x1 I cap plus y1 j cap plus z1 k cap. Okay, what is OB bar? OB bar is B bar. What is OB bar? As we know point B, we can write OB bar. What is OB bar? OB bar is x2 I cap plus y2 j cap plus z2 k cap. Okay, now to do this problem, in last what we did after writing the given data, look here, what is the step we written? First there is a line passing through point A parallel to given vector B bar. After that, what is the step you written? See, OP bar, let P of x comma y comma z is any point on the line L such that OP bar equal to, this is the point, same point we will take, right? Same concept. Okay, you need this one. Okay, right, move there. Where is that? Okay, right. Okay, right, keep it here. I am taking a point P. P of x comma y comma z is any point on the line L such that OP bar equal to R. You see here, this is let we are taking. So I need to mark some point P here anywhere. Pink color. Okay, this is same color. Okay, P. What is P? P is x comma y comma z. I taken P, a point, any point, anywhere, and not only here. I can take point P here or anywhere. P is any point on the line L such that OP bar equal to R bar. And as P is there, now P is x comma y comma z. OP bar can be written as xi cap plus yj cap plus zk cap. Okay, right. Now, AP bar and AB bar. What you say about AP bar and AB bar? Look here, AP bar. Look here, please. Where is AP? Here it is AP. AP bar and AB bar. What we can say? AP bar, AB bar. Can I say they are parallel? Yes, obviously they are parallel, right? Same like last concept what we used, same you can observe that last one, what way we derived, same. AP bar comma AB bar are parallel. You know that parallel vectors are also known as collinear vectors. If two vectors are parallel, one vector can be expressed as scalar multiple of another vector. So from this what we can write? I can write that AP bar equal to lambda times of AB bar. AP bar equal to lambda times of AB bar, right? What is AP bar? AP bar is OP bar minus OA bar equal to lambda times of what is AB bar? AB bar is OB bar minus OA bar. We can write like this. This we learned from vector algebra chapter. AP bar can be written as OB bar minus OA bar. AB bar can be written as OB bar minus OA bar. What is OP bar? Look here. What is OP bar? OP bar is R bar. Okay. I'll write all these things. OP bar is R bar. What is OA bar? OA bar is A bar. Look here. OA bar is A bar. Look here. OA bar is A bar. OB bar is B bar. Right? Equal to lambda times of OB bar is what? OB bar is B bar. OA bar is A bar. Now you take this minus A bar to the right hand side part. What you will get? You will get that R bar equal to A bar plus lambda times of B bar minus A bar. Right? What is this? R bar equal to A bar plus lambda times of B bar minus A bar. This is the equation of a line passing through 2 points whose position vectors are A bar, B bar respectively in vector form. Right? This is the equation of line. You need to memorize this. R bar equal to A bar plus lambda times of B bar minus A bar. Right? This is vector form. I'll write here. R bar equal to A bar plus lambda times of B bar minus A bar is the equation of a line. Is the equation of a line in what form? In vector form, passing through 2 points whose position vectors are A bar and B bar, right? You need to memorize this result. Now, what the thing here? We need to derive the equation of a line in vector form as well as Cartesian form. Vector form is over. Now, Cartesian form. Cartesian form. We'll derive that Cartesian form. Okay. Cartesian form. Cartesian form. So, in this formula, what are the things we need? Look here, we need A bar, B bar, R bar. All those things are there here. A bar. Look here. Right. A bar, B bar. These are A bar, B bar. And what is R bar? R bar also you written here. Look here. R bar equal to, look this one. R bar equal to xi cap plus yj cap plus zk cap, right? R bar. R bar equal to xi cap plus yj cap plus zk cap. Okay, A bar, B bar, R bar. Total 3 things are there. What is vector form? Vector form is this one. R bar equal to A bar plus lambda times of B bar minus A bar. From this only we will get the Cartesian form. Okay, first R bar. What is R bar? Here it is, then R bar is this one. Okay, R bar is this one. R bar equal to A bar. What is A bar? This is A bar. A bar plus lambda times of B bar minus A bar. I'll write this directly. B bar minus A bar. Look here. B bar, this is B bar minus a bar. B bar minus a bar, when you subtract, what you will get? X2 minus x1 into I cap, right? X2 minus x1 into I cap plus subtract y2 minus y1 into j cap. Okay, y2 minus y1 into j cap. Next plus z2 minus z1 into k cap. z2 minus z1 into k cap. Okay, right. Now here one more step we can write, but I just want to write that direct step. No problem, we'll write one more step. What is that one more step? This is as it is, this is as it is. Okay, equal to, now you see here also I term is there, here also I term is there. In these two you take I common, what you will get? You will get like this: x1 plus lambda times of x2 minus x1 into I cap. Okay, similarly y1 plus y2 lambda times of y2 minus y1 into j cap. Okay, plus z1 plus z2 minus z1 into lambda into k cap, okay, right. Now here this side one vector is there, this side another vector is there. You equate the scalar components. Here x equal to this one, y equal to this one, z equal to this one. You equate, what you will get? X equal to x1 plus lambda times of x2 minus x1. Okay, y equal to y1 plus lambda times of y2 minus y1. Okay, z equal to z1 plus z2 minus z1 into lambda. From this you try to write what is lambda. First you take x1 to this side, what you will get? X minus x1 equal to lambda times of x2 minus x1, right? Now you take it this to the left hand side, what you will get? X minus x1 divided by x2 minus x1 equal to lambda, right? So what you will get here? X minus x1 divided by x2 minus x1 equal to lambda, y minus y1 divided by, it can be understood easily, lambda, z minus z1 divided by z2 minus z1 equal to lambda. See, this is lambda, this is lambda, this is also lambda. So what you will get here? You will get that x minus x1 divided by x2 minus x1 equal to y minus y1 divided by y2 minus y1 equal to z minus z1 divided by z2 minus z1 equal to lambda, x minus x1 divided by x2 minus x1 equal to y minus y1 divided by y2 minus y1 equal to z minus z1 divided by z2 minus z1. This is the second formula you need to memorize. What is this? This is the equation of a line passing through 2 points, x1 y1 z1, x2 y2 z1. This is a method. This is the method of representing a line in a space in Cartesian form, right? Just a minute, water break. See, creating videos is not so easy. It's already 38 minutes is over. Please drop a like, share this video with your friends in case if you are watching till now, right? Okay, now what is next one? Vector form as well. Any note points are there for this? That's it. No note point for this. Right, next concept is angle between two lines. This is also we use as a formula. Total 3 things we are going to learn in today's class. Related to equation of a line, only 2 points are there. One is equation of a line passing through the point and parallel to the given vector. Another one is equation of a line passing through 2 points. Second one is, you look here. Third one, if theta is angle between two lines with the direction ratios a1 b1 c1, a2 b2 c2, Then what is the formula? Cos theta equal to a1 a2 plus b1 b2 plus c1 c2 divided by root over a1 square plus b1 square plus c1 square into root over a2 square plus b2 square into c2 square. Okay. Now we need to derive. I'll write the data first. Derivation proof. What is the first step? Let L1 comma L2 are two lines with direction ratios a1 comma b1 comma c1 and a2 comma b2 comma c2, and let theta is angle between lines. Theta is angle between lines L1 and L2. You suppose theta is the angle between the lines L1 and L2. What I'll do now, I'll take 2 points. Look here, P is the point on the line L1, Q is the point on the line L2. I suppose this is O. Okay, let P comma Q are 2 points. Let P comma Q are 2 points. Let P comma Q are 2 points on the lines L1 comma L2 respectively. That means P is a point on the line L1, Q is a point on the line L2. Now angle between these two lines is same as, what is P? As the direction ratios of L1 are there, na? Direction ratios of L1 is what? What are the direction ratios of this A1, B1, C1, right? So what I can write here, I can write OP bar. Before that, okay, I'll write here OP bar. What is OP bar? As we have direction ratios of L1, OP bar can be written as A1 I cap plus B1 J cap plus C1 K cap. OQ bar can be written as direction ratios of line L2. They given A2, B2, C2 na. So OQ bar can be written as A2 I cap plus B2 J cap plus C2 K cap. Okay, OP bar, OQ bar, two things are there. You observe the diagram, angle between OP bar comma OQ bar. Angle between OP bar comma OQ bar is nothing but angle between the lines L1 and L2, right? So what is see it, if theta, we learn dot product na. In dot product, if theta is the angle between the vectors OP bar comma OQ bar, what is cos theta formula? Dot product, cos theta equal to OP bar dot OQ bar divided by magnitude of OP bar into magnitude of OQ bar. Formula is there. Vector algebra. That's why I said in the beginning of this chapter only, if you want to learn 3D geometry, you must be good in vector algebra chapter. Okay, right. So here, angle between, I'll write the step. Angle between lines L1 comma L2 is same as angle between vectors OP bar comma OQ bar. So we have that angle between OP bar comma OQ bar formula, cos theta equal to OP bar dot OQ bar divided by magnitude of OP bar into magnitude of OQ bar. What is OP bar dot OQ bar? Here you know OP bar, OQ bar. Na? Dot product you already know in vector algebra chapter. What is the formula? OP bar dot OQ bar is what? A1 A2 plus B1 B2 plus C1 C2. Right, the same thing. OP bar dot OQ bar is A1 A2 plus B1 B2 plus C1 C2 divided by magnitude. What is magnitude of OP bar? Look here. OP bar is this vector. Now, what is the magnitude of OP bar? Root over A1 square plus B1 square plus C1 square into root over A2 square plus B2 square plus C2 square. Right? So this is the formula to calculate angle between two lines when they given direction ratios of the lines, right? If when they given direction ratios of the lines, then we can find angle between those two lines by using this formula. Here what is theta? Theta is angle between those two lines. If the lines are perpendicular, I'll give note point here. If lines are perpendicular, then what you know, if the lines are perpendicular, theta will become 90 degrees. Cos 90 degrees value is what? Cos 90 degrees value is 0. Now you cross multiply, take all the things to this side and multiply with 0. Then what you will get? You will get that a1 a2 plus b1 b2 plus c1 c2 equal to 0. If lines are perpendicular, then what you know, a1 a2 plus b1 b2 plus c1 c2 equal to 0, right? So total 3 things we done in this class. 45 minutes over. Okay, what I am planning here now, we'll do the problems related to these 3 formulas. One more concept is there in the second exercise, that is shortest distance between the skew lines. We'll do that. Before that, you get some grip how we use this theory part. Today's class is completely theory. How to use these formulas in today's class. What you need to memorize these things. You need to know what is r bar equal to a bar plus lambda b bar means. You need to say what is this. It is the equation of a line in vector form. Which line equation? The line passing through point A whose position vector is a bar and parallel to the vector b bar. You must be in a position to answer that. Then only you can do the problems. And what is this one? What is this one? This is the equation of a line in Cartesian form. Which line equation? The line passing to the point x1 comma y1 comma z1 and parallel to the vector ai cap plus bj cap plus ck cap. If you are in a position to answer this, then only we can start exercise problems. Next one. By seeing this, you need to say what is this? What is this? This is the equation of a line passing through 2 points whose position vectors are a bar and b bar in vector form. You must be in a position to answer that. And what is this? This is the equation of a line passing through 2 points in Cartesian form. Those 2 points, the line passing the 2 points x1, y1, z1, x2, y2, z2. If you are understand what I am telling now, you are ready to do the exercise problems, right? They given 2 lines with the direction ratios a1, b1, c1, a2, b2, c2. Then to calculate angle between those two, we use this formula cos theta equal to a1, a2 plus b1, b2 plus c1, c2 divided by root over a1 square plus b1 square plus c1 square into root over a2 square plus b2 square plus c2 square. This is the formula we use to find angle between the lines when they given direction ratios of the respective lines, right? And if 2 lines are perpendicular, then a1, a2 plus b1, b2 plus c1, c2 equal to 0. In next class, we will do the problems related to this 3 points. Once those problems are over, then separately we will do what is the derivation for distance between skew lines and what are the problems related to that. All those things we will do at a stretch. I hope you understand this class. If you like this video, please drop a like, share it with your friends. In case if you are not yet subscribed to my channel, subscribe now. And one more thing, if you want more courses, we have our own app. Android app. It is Android app only, not iOS app. Android app. App name is BR Max Class. Please go download and check the courses over there. It is helpful to me. Right. Thanks for watching. Take care. Bye bye.